Hello friends, in last lecture we discussed the fluid properties. Now we will discuss the bulk modulus of gases. Okay, so there are two types of bulk modulus. One is isothermal bulk modulus and one is isentropic, or you can say that it is adiabatic bulk modulus. Okay, so for gases there is isothermal cases and there is adiabatic cases. Sorry. So if there is isothermal cases, so PV equal to mRT, we know that this is the ideal gas equation. So from here you can say that P equal to rho RT. So dP by d rho, that is equal to R into T. So multiplied by rho in both sides, so rho dP by d rho, that is equal to rho RT. So rho RT means P. So rho into dP by d rho, we know that K. So rho into dP by d rho, we know that K. What is the K? K formula means rho into dP by d rho. Okay, we see in the previous lecture. So K, that is equal to P. So from here you can say that for isothermal cases K, that is equal to P, and bulk modulus we know that 1 by K. So beta, that is equal to 1 by P. Beta, that is equal to 1 by P. So for state 1 and state 2, P1 V1 equal to P2 V2, we can say that for isothermal cases. So P2, that is equal to P1 V1 by V2. Okay, so if you want to calculate the bulk modulus K, that is equal to P2, this P2 P1 V1 by P2 by V2, and beta, if you want to calculate beta, that is equal to 1 by P2. Okay, and for adiabatic cases, so for adiabatic, so adiabatic means that is isentropic process. Okay, entropy constant. So PV to the power gamma, that is equal to constant. Okay, from basic thermodynamics. So P into V, that is equal to m by rho to the power gamma, that is equal to constant. Okay, so from here you can say that P by rho to the power gamma, that is equal to constant. Okay, so from here phi equal to C into rho to the power gamma. Okay, so from here dP by d rho, that is equal to gamma into C. So gamma into C into rho to the power gamma minus 1, multiplied rho in both sides. So rho dP by d rho, that is equal to nu into C into rho to the power gamma minus 1. So here K is the adiabatic bulk modulus. Okay, K is the adiabatic bulk modulus. So rho dP by d rho, that is K. K into nu C rho to the power gamma, nu C rho to the rho into rho to the power gamma minus 1. So 1 cancel out. So rho to the power gamma. So K, that is equal to nu into P. P equal to C rho to the power gamma. So C rho to the power gamma, that is P. So nu into P. Okay. So if you want to calculate the beta, that is equal to 1 by nu into P, 1 by bulk modulus, we know that. And for process 1 to 2, so P1 V1 to the power gamma, that is equal to P2 V2 to the power gamma. So from here P2, that is equal to P1 V1 to the power gamma divided by V2 to the power gamma. So if K2, that is equal to gamma P2, then beta, that is equal to 1 by gamma P2. Okay, so now there is another one problem is there. So a cylinder contain 0.35 meter cube of air at 276 kilonewton per meter square absolute pressure. Okay, the air is compressed to 0.071 meter cube. Assuming isothermal condition, what is the bulk modulus of elasticity at new state? And second, the adiabatic bulk modulus of elasticity at a new state if the specific heat ratio for air gamma, that is equal to 1.4. It is given in the question. So what is given in this question? So a cylinder contain 0.35 meter cube of air. So initial volume, that is V1, that is 0.35 meter cube at 276 kilonewton per meter square absolute pressure. So P1, that is equal to 276 kilonewton per meter square, and the compressed volume, that is 071. So V2, that is equal to 071 meter cube. So if you want to calculate, so for first case there is a isothermal condition. So isothermal means temperature that is equal to constant. So you can apply P1 V1, that is equal to P2 V2. So from this formula you can calculate the P2, that is equal to P1 V1 by V2. So from here 276, that is the pressure, into V1, that is the initial volume, that is 0.35 by 0.071. So from here you can calculate that this is equal to 1360.6 kilonewton by meter square. So 1.36 mega, m is the mega, capital M, mega Newton per meter square. Okay, so I know from the isothermal condition that K that is equal to P, so K that is equal to P2, so that is equal to 1.36 mega Newton per meter square. So this is the answer. So in that question, what is the bulk modulus of elasticity at new state? So the answer is 1.36 mega Newton per meter square. Okay, now for second case, the adiabatic bulk modulus of elasticity at new state is specified, if specified heat ratio for air that is equal to 1.4. So gamma is given in that case, and this is the adiabatic process. So you can apply P1 V1 to the power gamma that is equal to P2 V2 to the power gamma. So P2 that is equal to P1 V1 to the power gamma by V2 to the power gamma. So that is equal to P1 value is given 276, V1 that is the initial volume that is 0.35 to the power 1.4 divided by V2 0.071 to the power 1 by 4. So from here you can calculate that 2.575 mega Newton per meter square. So from adiabatic equation we know that K that is equal to gamma into P2, so you have to multiply. So remember this, for adiabatic process you have to multiply with gamma. Gamma is the specific heat ratio that is given in this question, that is 1.4. Okay, so 1.4 into 2.575 mega Newton per meter square, the answer would be 3.61 mega Newton per meter square. So this is the answer. Now in next topic we will discuss the speed of sound or acoustic speed or pressure wave velocity or sonic speed. It is denoted by capital C. So C, that is the formula, that is C equal to under root dB by d rho, and we know that K equal to, what is the K formula? K that is equal to rho into dP by d rho. So from here that is equal to under root K by rho. Okay, so from bulk modulus formula we know that K, so that is equal to under root K by rho. So this is applicable for liquid and gases. Okay, so K that is equal to, we know that that is dP by d rho by rho. So dP by d rho that is equal to K by rho. So here dP by d rho that is equal to K by rho. So under root K by rho. So for gases, C that is equal to under root K by rho, and for adiabatic process that is K equal to gamma into P. So C that is equal to K by rho. K, we know that K equal to gamma into P by rho. So gamma into P equal to rho RT by rho. So for adiabatic process C equal to gamma into R into T. So C equal to under root gamma RT. Okay, so this is very, very important. Now we will understand what is the Mach number. So it is the ratio of object speed that is denoted by V to the speed of sound C. So Mach number MA that is equal to V by C. So if Mach number is less than 1, then V less than C, this is the subsonic flow. You can say that this is the subsonic flow. If Mach number equal to 1, then V equal to C, it is known as sonic flow. And if Mach number greater than 1, that is V greater than C, that is a supersonic flow. And if Mach number is greater than 5, then V greater than C, this is known as hyper supersonic flow. Okay, this is known as hyper supersonic flow. Now now consider this is a aeroplane nose. Okay, so this is the aeroplane nose. Here this is the aeroplane nose, and here the stagnation point, and so the fluid is coming in this way and going and in that way. So this point is the stagnation point. Stagnation means velocity that is equal to 0. Okay, so if you apply in the streamline Bernoulli's equation, P by rho g, P by omega plus V square by 2g plus z. So this is the initial condition, and this is the final condition, P0 by rho g. So P0 is the pressure at stagnation point. P0 by omega plus V is the velocity, stagnation velocity, that is equal to 0 plus z. So this is the stagnation head, and this is the datum head, and this is the dynamic head, and this is the static head. Okay, so if you want to calculate P0 by omega minus P by omega, that is equal to V square by 2g. So P0 minus P by omega, that is equal to V square by 2g. Okay, so dP, so P0 minus P, you can say that this is dP, and omega that is equal to rho into g, that is equal to V square by 2g. So d rho by rho that into dP by d rho. Okay, so dP by d rho, you can write in this way, that is equal to v square by 2. So from here you can say that v by c, that is equal to under root 2 into d rho by rho. Okay, so for incompressible flow we know that d rho by rho percentage, that is less than 5%. So d rho by rho, that is equal to 0.05. This is 5%, so that is why this is 0.05. So Mach number less than under root 2 into 0.05. Okay, so 2 is coming in this, from this. Okay, so Mach number less than 2 into 0.05. So Mach number less than 0.32. So this is very important. Now for air, if we know we know that the air have the C value, C, that is sound of air, that is equal to 332 meter per second. Sound velocity in air, that is 332 meter per second. So V by 332 less than 0.32. So V less than 0.32 into 332. So V less than 106. So this is my handwritten notes. You can download it from the description. The PDF notes are available. Okay, thank you.